All right.
All right. Here we go again.
I finished my dinner, so we're good. I'm at full brain capacity now.
There you go. No longer hangry.
No longer hungry. I have class from noon until 6:30, and then I just have to run home really quick and get on here.
Oh, wow. That's a lot. That's a long day.
Yeah, Tuesdays. That's when they told us to do these group meetings. I'm like, you've got to be kidding me.
I know, right? I'm just grateful this is the only class I have of the 4 that I have a group meeting for. The rest, yeah. I don't have any discussion boards or anything. I'm thrilled.
Wow, that's awesome.
Yeah.
Discussion boards? That is so nice.
No, not in the other. I know. It's like the worst, isn't it? To have them.
The epitome of every online class.
I mean, I love discussions, but discussion boards, it's just not productive in my mind.
They're not. They're rarely effective.
I think we should petition them.
Yeah. All right. So any questions on lesson 7? Anything anyone wants to review?
I think we'll go through it.
All right. If not, we can just go on to our quiz.
All right.
Was it my turn when we left off? I'll just read the first one.
Yeah, sure.
Okay.
Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358, and to the left of z negative 1.358. Round to 3, yeah, example, blah, 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 blah. Cool. So is that the whole, like, z equals the variable minus the mean? Oh, wait, no, kidding.
Yeah, I think it's just 0.8255, 0.826.
Wait, did you already put that in the probability applet?
Uh-huh. I just put 1.358.
Okay.
0.8255. Is that what you guys got?
So,
oh wait, I'm getting 0.1745.
That's what I got too.
Are you
Because it's just the outsides?
Oh, it went to both, right? Both on the left and the right side?
Uh-huh.
Yeah, I got 0.1745.
Wow, how am I getting that so wrong?
What'd you put in your Z-score?
Oh, I'm seeing what, okay, yeah, never mind. I was reading that wrong. So it's 0.1745, so 0.175?
Yeah,
that's
I'm thinking. All right. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? Okay.
Can we determine that?
I don't think so.
I don't really know. I'm kind of confused by this question.
I am too.
Which of the following have a smaller?
If the standard deviation, which will have a smaller means gets smaller, the values of x will be very close to each other. I wrote down this note, and I don't know if this pertains to this or not, but it says, if the standard deviation of the sample mean gets smaller, the values of the x will be very close to each other and therefore close to u. The sample size is large.
That means it would be B?
We could try that, and if it's not, I guarantee if it's not B, it's got to be C.
Yeah,
Okay.
yeah. I think you're right. Let's try B.
Sounds good.
All right.
Okay, I'll do number 5. Which of the following results implies that the spread in X decreases as the sample size increases?
I think that's the
So-
law of large numbers.
Mhm.
Yeah, I think it's large numbers.
Yep.
And 6. So I'm just going to read through that real quick. So scores of the quantitative portion of the GRE are approximately normally distributed with the mean and the standard deviation at those numbers. And then so that Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score? Okay, so would this be where we apply that new Z-score one where it's
Yeah, like
X?
Yeah,
X minus M
Exactly.
over the standard deviation, whatever.
Yeah.
Square root.
that'd be the 160 minus 150.8,
Mm-hmm.
Mhm.
then divided by the 8.8 divided by the square root of, is that just 1? Because it doesn't give us our sample size.
Do we use the square root for this one?
Oh, you might not have to, because I know in the
Yeah.
notes you were using the old formula for a couple of them.
Yeah.
I noticed that too. And even if you did do the square root of 1, it's still 1. So, you know, still the
Right.
same answer.
So what'd you guys get? I got like 1.045.
Yeah, that's what I got.
Okay, cool.
Divided by
Yep.
8.8. 1.045, yep.
Yeah.
Round decimal to 3 decimal places. 1.045.
All right. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Okay.
Well, we have the Z-score from the previous question. We can just plug that in, right, to the applet?
0.148.
1.045.
So I got the area of 0.148.
Mm-hmm.
So that'll just be to the right, correct?
Yeah.
Oh, we're just on the right side. Okay, cool. That explains why I got it wrong. Yeah, I got it right now. Cool.
Great. All right. Okay, number 8. A random sample of 5 students was selected to take the GRE. Their scores are, this is the Z-score corresponding to the sample mean of these students' scores. So do we need to find the mean of that first?
Yeah, we
Yeah.
think so.
I think it's 160, right? Oh, no, never mind. Discredit what I just said.
Okay. 160, 175, 163,
got 160.
149.
All right, I think I missed a number.
160.
160.
Oh, wait.
That's what I got.
What is the Z-score corresponding to the sample mean of these students?
So we need to find the standard deviation too.
Yeah, so 160.
I'm just going to put it into Excel because I hate calculating that. 175. 160.
So what exactly were we subtracted by? Because it's
So-
like a variable subtracted by the mean. Do we just plug in any of those numbers?
No, the mean is 160. So
The standard deviation is 10.050 as well.
okay.
So it'd be 10.5, 10.05.
Okay, and then the mean is 160. So are we looking for So we're actually looking for the z-score. So what is the sample?
That's a good question. What's the probability?
It's 5 students, so it'd just be 5, wouldn't it?
That's what I thought. Yeah, it'd be
Yeah,
5.
that's the sample number, but what's our x in the equation?
Yeah,
Yeah,
I don't
that's
think it
the-
would be very well if we did
really-
5 minus 160. Right? I don't think
Do
that's.
we
So
refer
it's just like pick the
to
median?
those? Let's see. I think we use the mean up above, the 150.8 that we were using in the prior questions. Because it says for the next 4, so 6, 7, 8, and 9.
Oh. Okay.
Okay.
So our x is our 160 that we just got,
Yeah.
and then we minus that by the 150.8, right?
Wait, so we do 160 minus 150.8 or the other way around?
Yeah. Yeah. Mhm.
60 minus 150.8, yeah.
Okay.
And then our standard deviation would then be that 8.8 up there,
Right.
divided by the square root of 5.
Let's calculate the standard deviation from those 5 numbers.
Or don't you we still divide it by the standard deviation, right?
Right. I don't
Well, they
think we
gave
do
us the
square root
standard
of 5.
deviation, right?
Yeah.
Or do we do the
I think for these ones we just do the standard deviation, or we just do the z-score of 1.045.
I'm kind of confused.
Or do we divide that standard deviation by n?
Hmm.
'Cause I don't feel like we have the n variable.
Well, isn't it 5? Because we have 5 grades here, 5 students.
Right. That would be the sample.
Let's see.
So we're thinking that the problem that we're going to do is 160 minus 150.8 over the standard deviation of 8.8 over the square root of 5.
Yeah, that's what I'm thinking.
Okay, let me plug that in real quick.
Which gives me an answer of 0.4675. So 4.468.
I'm gonna double check that. Just to...
Yeah, please do.
All right. What did you get again, Ginger?
0.4675.
Oh wait, I gotta type in the z-score. Just kidding.
Okay, I got
Oh, that is my
0.234.
z-score. I guess that is the z-score. Is that what we're looking for?
Oh, that was
Yeah.
the z-score. Because I
Yeah,
got
what is the z-score
2.337.
corresponding to the sample mean of these students' scores? That's what we're looking for, right? Is the z-score?
Yeah. The z-score I got was 2.337.
That's what I got.
Yeah, that's what I
Okay.
got. Did you divide? Because you have to do like order of operations. You have to divide the 8.8 by square root of 5 before you divide it by.
Yeah,
160
I
minus
think that's what I did.
150.8.
I tried to do it all as one. Yeah, when I punched it in, I think that's what happened. So I'm always afraid I'm going to mess up when I try and round the numbers on my own. Okay.
It's all good.
What was the answer to number 7 again? Sorry.
0.148.
0.148.
I accidentally put that into the wrong ones.
So what answer did you guys get for the z-score?
2.338.
That's what I got.
Okay.
All right.
Awesome.
Number 9.
2.338.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Okay.
We put in that z-score into the normal probability output.
Yeah, I think so. 2.338 And then
so I
just
got-
shade to the right?
Right. I
Yeah,
got
0.0097.
Yeah.
Would that round up to
That's what I got.
0.01?
So would we put in 0.009?
Let's go 4 decimal places.
Okay, so
0097.
Oh, okay, cool.
Should be consistent. Some of them say 3 decimal places, some say 4. Yeah, okay.
Good catch. Okay, I think that's me. What is the shape of the sampling distribution of the random variable, which represents the sample mean of the 81 students who are selected?
What? PA is 3.5 standard. Well known.
Wouldn't that just be approximately normal?
Yeah, because
it's over
there's
30.
81 students. Yeah. So it's going to get closer to normal.
So C.
Right.
yeah,
Then 11. I can do 11. What is the mean of the distribution of the sample means, sampling distribution, for all possible samples of size 81 that could be drawn from the parent population? Ooh, that's an annoying question. What is the mean of the distribution of the sample means? I think that's just the mean it gives us, right? 3.5?
Yeah, I agree. Yeah. Because
Oh, wait, just
any,
kidding. Okay, sorry. This is a multi-level
yeah, it
question.
kind of is like that one where we had to share, you know, the salary, the mean of the salaries, because, you know, we're all going to be close to that sample mean. So anytime they do a sample size of 81, it's going to be close to that.
Yeah.
Okay. All right, I'll do number 12. What is the standard deviation of the distribution of the sample mean sampling distribution for all possible samples of size 81 that could be drawn from the parent population? Round your answer to 3 decimal places. So would that be the same thing as what they have up there is 0.7?
for the standard deviation.
I want to say yes, but at the same time, you remember the last one where we guessed that it was 6 and it turned out to be 1?
Yeah.
Would it not be that same way?
Oh,
I mean, the beauty of this is we can always submit it again, so.
Right.
so we could take 7.7 divided by the square root of 81.
81, right?
No.
0.077 or 0.078 would be our other option.
It does tell us to round it to 4 decimal points or 3 decimal points, so I think it would probably be, you know, not 0.7, if that makes sense.
Yeah, the 0.078 then.
Yeah. Let's try that.
At the same answer you guys got?
How did you come by that one? Was that just the...
Yeah, just doing the, what's that number? The standard deviation divided by the square root of 81.
Okay.
0.7 divided by 9.
Yeah.
Cool. All right.
Yeah, do you guys got 0.077?
Yeah.
78, I guess.
Wait, how many do we round that? It's 3 decimal places, so yeah, so
Well,
0.078.
0.078. Okay. All right. That the mean GPA for 81 randomly selected BYU students will be less than 3.3.
So this will do the equation, right? 3.3 minus 3.5
Yeah.
divided by our, what was the,
0.7 over. Do we do that over the square root of 81?
Yeah, I think all we have to do
I think
is
so.
3.3 minus 3.5 divided by 0.078, right?
I'm kind of confused
Oh,
as to
right.
when we divide by just the standard deviation or when we divide by the standard deviation divided by the square root of n. Like, I don't know when we do.
I think when it gives us a sample size, that's when we use the square
Okay.
root.
Okay.
All right, so I got a negative 2.564.
Yeah, that's what I got.
Yep.
But then we want what's the probability we want out of that?
So we need to put that in the applet.
Yeah, and then
Wait, you got negative 2.57?
2.564.
Oh, that's weird.
You go to 4 different places.
I got
Do
2.5.
we? Well,
Yeah.
either way, actually, wait.
So I did 3.3 minus 3.5 over 0.7 divided by the square root of 81.
and then wouldn't we just shade to the left of the negative z-score?
Yeah,
So it'd be
because
0.0052.
we want all the ones that are less than, right? Yeah. So I got 0.0052.
That's what I got.
Yeah, I got 0.005.
Oh, it says to just put it in 3 decimal places, so that's 0.005.
Is that making sense, Dorothy?
Yep.
All right, cool. I'll read the next one. That for 81 randomly selected BYU Idaho students will be greater than 3.3.
So wouldn't we just shade above the
Yeah, shade everything but to the left.
0.9948?
Yep.
So 0.995.
All right, one more.
All right, I'll read this one. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weight is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean that was observed in the sample. Round your answer to 3 decimal places. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we just observed, but also far away from the mean, as ours in the positive direction.
Okay.
Okay.
So
So do we have to do the z-score thing?
and then on the applet, we would just do the 2 outside regions.
Yep.
All right. So 185 minus 177 over 26.7 divided by the square root of 48.
Perfect.
That's all right. All right.
185.
So my phone's on low battery. I'm gonna go run and grab my charger real quick.
Okay.
Go right ahead.
Do we know what the standard deviation is 26.7?
Mm-hmm.
Okay, I got a z-score of 1.92018.
I did too.
I'll test that.
1 point.
All right, which gave me an area of 0.02.
Well, we want to do both sides, the right and the left side.
Oh, that's right.
So 0.0547.
Yeah. Well, so I got 0.0549. Did you just put in, were we supposed to put in a lot?
We just go 3 decimal places. So
Okay.
we'll get the same answer.
0.055.
Yeah.
All right.
Oh, yeah, that makes sense.
Okay, I'll go ahead and submit. It's always that moment of anxiety while it's calculating. Okay, so
Yeah.
3 we got right, 4 we got right, 5 is right, 6 is right, 7's right, 8's right, 9's right, 10's right, 11 is right, 12's right, 13's right, 14's right, 15's right.
Awesome.
Woohoo! All in one attempt.
Cool. Did you get,
Yeah.
sorry, I kind of
All
ran out
right.
of the room. Did you get
Nice.
0.027
For which answer?
for 15?
15.055, because you need to have both extremes on the low end and the high end.
Oh, that's why, duh. Okay, I'm just stupid. Cool, yeah.
No, you're not.
0.05.
No, you're not. This is just complicated.
All right, sounds good.
All right, so is everybody good? You got
Yeah.
all the answers, James?
Yeah, last one was 0.0549.
Yeah, only put
Yeah, so you just-
0.055.
Well, yeah, 3, yeah, 5. All right, cool. Yeah, we're good. I shade both sides. We're good.
All right. Have a great one. We'll see you guys next Tuesday.
Yep. Take care.
All right,
Bye.
sounds
Bye.
good. Yeah. Thanks.